Welcome, friends. Tonight we quiz to sleep, learning about the universe. Across 15 quiet sections, from the origins of the cosmos to distant galaxies and exoplanets, you'll hear slow, reflective questions that guide you into calm clarity. A soft 7 Hz tone, layered with gentle pink noise rainfall, plays beneath the voice, anchoring your mind in stillness to support deep sleep and memory consolidation. There are no correct answers tonight, no pressure, no judgment. You'll hear each question, feel a pause, and drift further, letting the knowledge settle gently into your subconscious. Sleep deeper, wake brighter. Section 1. What is astronomy? Exploring the oldest science known to humankind, where we observe the heavens not just for wonder, but for patterns, motion, and meaning. Astronomy helps us understand our place in the cosmos, how stars are born, why galaxies spin, and what lies beyond the edge of our night sky. First question, what is the primary difference between astronomy and astrology? A. Astronomy is based on scientific observation, while astrology interprets human events through celestial movements. B. Astronomy focuses on lunar calendars, while astrology uses solar charts. C. Astronomy relies on mythology, while astrology uses modern data. Answer. A. Astronomy is based on scientific observation, while astrology interprets human events through celestial movements. Astronomy is a science that seeks to understand the universe through evidence, while astrology is a belief system that lacks empirical support. Which tool revolutionized astronomy in the early 1600s? A. The microscope. B. The telescope. C. The sundial. Answer. B. The telescope. The telescope allowed early astronomers like Galileo to view celestial objects in unprecedented detail, transforming stargazing into a data-driven science. Which branch of astronomy deals with collecting and analyzing light from celestial objects? A. Theoretical astronomy. B. Optical engineering. C. Observational astronomy. Answer. C. Observational astronomy. Observational astronomy uses telescopes and detectors to gather real-time data from the universe, often across multiple wavelengths. Which of the following best describes theoretical astronomy? A. Hands-on measurement of star brightness. B. Creating models and simulations of cosmic phenomena. C. Testing rocket propulsion in low Earth orbit. Answer. B. Creating models and simulations of cosmic phenomena. Theoretical astronomy uses physics and mathematics to explain observations and predict new discoveries like black holes or dark matter. What do radio telescopes detect? A. Visible light from stars. B. Gravitational waves. C. Long wavelength radio signals from space. Answer. C. Long wavelength radio signals from space. Radio telescopes capture invisible radio waves emitted by celestial objects like pulsars, quasars, and even distant galaxies. Why are space telescopes like Hubble so important? A. They can be launched into black holes for data. B. They avoid atmospheric distortion for clearer images. C. They are cheaper than ground-based telescopes. Answer. B. They avoid atmospheric distortion for clearer images. Earth's atmosphere blurs and blocks some light. Space telescopes avoid this, providing ultra-clear views of the cosmos. Which ancient civilization first recorded detailed star charts around 1200 BCE? A. Mayan. B. Babylonian. C. Roman. Answer. B. Babylonian. The Babylonians created meticulous astronomical records that helped future civilizations track planetary movements and eclipses. What does the word astronomy literally mean in Greek? A. Star law. B. Night knowledge. C. Sky math. Answer. A. Star law. Astronomy comes from the Greek words astron, star, and nomos, law. The study of the laws governing stars and celestial bodies. Section 2. The universe, size, age, and origin. In this section, we explore the vastness of space, the beginning of time, the size of the observable universe, and the quiet remnants of its explosive birth. What we see in the night sky is only a glimpse of something far grander. Billions of galaxies stretching across expanding space. What does the Big Bang Theory propose? A. That the universe has always existed in its current form. B. That the universe expanded from a hot, dense point around 13.8 billion years ago. C. That galaxies formed randomly without a beginning. Answer. B. That the universe expanded from a hot, dense point around 13.8 billion years ago. The Big Bang Theory is supported by strong evidence, including cosmic microwave background radiation and the redshift of galaxies. What is the current estimated age of the universe? A. About 4.6 billion years. B. About 9.2 billion years. C. About 13.8 billion years. Answer. C. About 13.8 billion years. Scientists calculate the age of the universe by observing distant cosmic objects and measuring the cosmic microwave background. What is the cosmic microwave background? A. Microwave emissions from nearby stars. B. Radiation left over from the early universe. C. Static caused by the sun's corona. Answer: B. Radiation left over from the early universe. The cosmic microwave background is a faint glow that fills the universe. Radiation from when the universe was just 380,000 years old. What is meant by the expansion of the universe? A. Galaxies are growing in size. B. Space itself is stretching, moving galaxies apart. C. The solar system is drifting toward the Milky Way's edge. Answer: B. Space itself is stretching, moving galaxies apart. The expansion of the universe refers to the increase in distance between galaxies, not because they're moving through space, but because space itself is expanding. What is redshift in astronomy? A. A shift in starlight toward red due to lower temperatures. B. The Doppler effect causing light from distant galaxies to stretch. C. Light affected by the sun's magnetic fields. Answer: B. The Doppler effect causing light from distant galaxies to stretch. Redshift shows that galaxies are moving away from us, evidence that the universe is expanding in all directions. What is the observable universe? A. The part of the cosmos visible from Earth with the naked eye. B. A local bubble of stars inside the Milky Way. C. The portion of the universe we can detect, limited by the speed of light. Answer: C. The portion of the universe we can detect, limited by the speed of light. Because light takes time to travel, we can only see objects whose light has had time to reach us, making the observable universe finite, even if the full universe is larger. What lies beyond the observable universe? A. Empty space with no matter. B. Nothing, because the universe ends there. C. Potentially more galaxies we can't yet see. Answer: C. Potentially more galaxies we can't yet see. The observable universe is bounded by what we can measure, but beyond that may lie countless galaxies forever hidden by the limits of light, speed, and time. What is the shape of the universe according to current models? A. Perfectly spherical. B. Flat with slight curvature depending on density. C. Shaped like a donut with a central void. Answer: B. Flat with slight curvature depending on density. Most current evidence suggests the universe is flat on large scales, meaning parallel lines remain parallel as space stretches. Section 3. Light and telescopes. Before we knew what stars were made of, we watched their flickers. Before we could reach space, we learned to listen to light. Telescopes gave us eyes, spectroscopes gave us voices, and light, stretched, bent, and split, revealed the secrets of the stars. What part of the electromagnetic spectrum is visible to the human eye? A. Ultraviolet light. B. Visible light. C. Infrared light. Answer: B. Visible light. Visible light is just a tiny slice of the electromagnetic spectrum between infrared and ultraviolet. What does a spectroscope do? A. Measures gravitational waves. B. Magnifies distant objects in space. C. Breaks light into its component wavelengths. Answer: C. Breaks light into its component wavelengths. Spectroscopes split light like a prism, letting scientists study the composition, motion, and temperature of stars and galaxies. Which type of telescope uses mirrors to gather and focus light? A. Refracting telescope. B. Reflecting telescope. C. Radio telescope. Answer: B. Reflecting telescope. Reflecting telescopes use curved mirrors to gather more light and provide clear, focused images of celestial objects. What is one advantage of a refracting telescope over a reflecting one? A. It captures more radio waves. B. It avoids issues with mirror alignment. C. It is more durable for satellite use. Answer: B. It avoids issues with mirror alignment. Refracting telescopes use lenses which don't require the same realignment or maintenance as mirrors, but they can suffer from chromatic distortion. Which type of telescope would best detect cold dust clouds in deep space? A. Infrared telescope. B. Ultraviolet telescope. C. Optical telescope. Answer: A. Infrared telescope. Infrared telescopes can see heat and are ideal for detecting cooler objects like dust clouds, protostars, and planets. What is blue shift? A. A decrease in star temperature. B. Light shifting to shorter wavelengths as an object approaches. C. A change in a star's chemical makeup. Answer: B. Light shifting to shorter wavelengths as an object approaches. Blue shift happens when a celestial object moves toward us. Its light compressed, shifting toward the blue end of the spectrum. Which type of telescope detects wavelengths longer than visible light? A. X-ray telescope. B. Gamma ray telescope. C. radio telescope. Answer: C. Radio telescope. Radio telescopes detect long wavelength radio waves emitted by objects like quasars, pulsars, and interstellar gas. Which modern telescope or mission revealed high-resolution images of distant galaxies and nebulae from above Earth's atmosphere? A. Kepler Space Telescope. B. Hubble Space Telescope. C. Voyager 2. Answer: B. Hubble Space Telescope. Launched in 1990, the Hubble Space Telescope transformed astronomy with stunning, detailed images unobstructed by Earth's atmosphere. Section 4. Stars, Formation and Life Cycle. Stars are born from clouds of dust and gas, tiny ripples that ignite into fusion-powered suns. They live for millions or billions of years, shining steadily or flaring in cataclysmic finales. In their death, they seed the universe with the very elements we're made of. Where do stars form? A. In planetary rings. B. Inside comets. C. Within nebulae. Answer: C. Within nebulae. Nebulae are vast clouds of gas and dust, stellar nurseries where gravity pulls matter together to form new stars. What causes a protostar to become a main sequence star? A. The collapse of a black hole nearby. B. The onset of nuclear fusion in its core. C. The cooling of its outer layers. Answer: B. The onset of nuclear fusion in its core. A protostar becomes a main sequence star when hydrogen fusion begins, converting hydrogen into helium and producing light and heat. What determines how long a star will live? A. Its distance from Earth. B. Its color. C. Its mass. Answer: C. Its mass. Massive stars burn through fuel quickly and die young, while smaller stars burn slower and live much longer. What kind of star is our Sun classified as? A. White dwarf. B. Red supergiant. C. G-type main sequence star. Answer: C. G-type main sequence star. The Sun is a medium-sized yellow G-class star, stable and steadily fusing hydrogen in its core. What happens when a massive star runs out of fuel? A. It becomes a comet. B. It collapses and explodes in a supernova. C. It evaporates into space. Answer: B. It collapses and explodes in a supernova. A supernova is a powerful explosion that occurs when a massive star's core collapses, blasting elements across the galaxy. What can be left behind after a supernova? A. A nebula only. B. A white dwarf. C. A neutron star or black hole. Answer: C. A neutron star or black hole. After a supernova, the core may compress into a dense neutron star, or if massive enough, collapse further into a black hole. What is a red giant? A. A dying star that has expanded and cooled. B. A newborn star still gathering mass. C. A galaxy core about to collapse. Answer: A. A dying star that has expanded and cooled. As stars run low on hydrogen, they expand into red giants, growing larger and cooler before shedding their outer layers. What is a white dwarf? A. The cold core of a planet. B. A dead star that still glows faintly. C. A type of quasar. Answer: B. A dead star that still glows faintly. White dwarfs are the dense remnants of small to medium stars like our Sun, no longer fusing but still glowing from stored heat. Section 5. The Sun. Our closest star, source of light, warmth, and weather. The Sun is a dynamic ball of plasma, bubbling with energy and rhythm. It may seem constant, but beneath its glow are storms, cycles, and a nuclear engine that powers life itself. What process powers the Sun's energy? A. Nuclear fission. B. Combustion of gases. C. Nuclear fusion. Answer: C. Nuclear fusion. The Sun fuses hydrogen into helium in its core, releasing vast amounts of energy that travel outward as light and heat. What layer of the Sun generates its energy? A. The core. B. The corona. C. The chromosphere. Answer: A. The core. The Sun's core is under immense pressure and temperature, where nuclear fusion occurs, fueling the entire star. What is the Sun's outermost layer, visible during a solar eclipse? A. The photosphere. B. The corona. C. The convection zone. Answer: B. The corona. The corona is the Sun's glowing outer atmosphere, visible as a halo during total solar eclipses and millions of degrees hot. What are sunspots? A. Holes in the Sun's surface. B. Cool, dark patches caused by magnetic activity. C. Collisions with meteoroids. Answer. B. Cool, dark patches caused by magnetic activity. Sunspots appear dark because they are cooler than surrounding areas, linked to magnetic field disturbances. What is a solar flare? A. A sudden burst of energy from the sun's surface. B. A reflection of Earth's magnetic field. C. A slow cooling process on the solar core. Answer. A. A sudden burst of energy from the sun's surface. Solar flares are intense bursts of radiation from magnetic activity, capable of affecting satellites, radio signals, and even power grids. What zone lies just outside the sun's core, where energy is transferred by radiation? A. The convective zone. B. The photosphere. C. The radiative zone. Answer. C. The radiative zone. In the radiative zone, photons bounce and scatter their way outward, taking thousands of years to escape. Why is the sun essential for life on Earth? A. It maintains Earth's gravitational orbit. B. It provides light, heat, and energy for photosynthesis. C. It reflects solar wind back into space. Answer. B. It provides light, heat, and energy for photosynthesis. The sun drives climate, seasons, and plant growth, making life as we know it possible on Earth. Section 6. The Solar System Overview. From the sun's fiery grip to Pluto's icy drift, our solar system is a cosmic neighborhood shaped by gravity, collisions, and time. Planets, moons, asteroids, and comets all orbit a common star, each carrying clues about how it all began. What theory best explains the formation of our solar system? A. Collision of two galaxies. B. Capture of rogue planets by the sun. C. Nebular hypothesis. Answer. C. Nebular hypothesis. The solar system likely formed from a rotating cloud of gas and dust, called a solar nebula, which collapsed under gravity 4.6 billion years ago. Which planets are considered the inner planets? A. Mercury, Venus, Earth, and Mars. B. Jupiter, Saturn, Uranus, and Neptune. C. Earth, Mars, Jupiter, and Saturn. Answer. A. Mercury, Venus, Earth, and Mars. The four inner planets are small, rocky, and lie closest to the sun, unlike the outer gas and ice giants. What separates the inner and outer planets? A. The Kuiper Belt. B. The Oort cloud. C. The asteroid belt. Answer: C. The asteroid belt. The asteroid belt lies between Mars and Jupiter, filled with rocky debris left over from the early solar system. Which planet has the most moons? A. Earth. B. Saturn. C. Venus. Answer: B. Saturn. Saturn currently holds the record for the most confirmed moons, including Titan, which is larger than Mercury. Which of the following is not a gas giant? A. Jupiter. B. Neptune. C. Mars. Answer: C. Mars. Mars is a terrestrial planet, rocky and compact, unlike the outer gas and ice giants. What are comets mostly made of? A. Molten lava and metal. B. Rock, dust, and frozen gases. C. Radioactive elements. Answer: B. Rock, dust, and frozen gases. Comets are icy visitors from the outer solar system, leaving glowing tails when they near the sun and begin to sublimate. What is the Kuiper belt? A. A ring of planetary debris near Earth. B. A distant region beyond Neptune filled with icy bodies. C. A ring of fire on the sun's surface. Answer: B. A distant region beyond Neptune filled with icy bodies. The Kuiper belt contains dwarf planets like Pluto, as well as many frozen leftovers from the solar system's early days. Section 7. Earth, Moon, and Tides. We orbit the sun with grace and spin through space without feeling it, but even here, on our pale blue dot, celestial mechanics shape the rhythms of day, night, seasons, and the pull of the tides. What causes day and night on Earth? A. Earth's orbit around the sun. B. The tilt of Earth's axis. C. Earth's rotation on its axis. Answer: C. Earth's rotation on its axis. Earth spins once every 24 hours, creating a cycle of daylight and darkness across its surface. How long does it take the Earth to complete one full orbit around the sun? A. About 24 hours. B. About 365 days. C. About 30 days. Answer: B. About 365 days. 1 year is the time it takes Earth to travel once around the sun, about 93 million miles along an elliptical path. What causes the seasons on Earth? A. The changing speed of Earth's orbit. B. Earth's distance from the Sun. C. The tilt of Earth's axis. Answer: C. The tilt of Earth's axis. Earth's axis is tilted about 23.5 degrees, causing different parts of the planet to receive more or less sunlight during its orbit. What causes the phases of the Moon? A. Earth's shadow passing over the Moon. B. The Moon changing shape. C. The angle of sunlight as the Moon orbits Earth. Answer: C. The angle of sunlight as the Moon orbits Earth. The Moon's phases result from how sunlight strikes its surface, changing how much of the lit half we can see from Earth. What is a lunar eclipse? A. When the Moon passes between Earth and the Sun. B. When the Moon reflects extra sunlight. C. When Earth passes between the Sun and the Moon. Answer: C. When Earth passes between the Sun and the Moon. In a lunar eclipse, Earth blocks sunlight from reaching the Moon, casting a shadow that can turn it deep red. What causes ocean tides on Earth? A. Earth's orbit speed. B. Solar flares. C. Gravitational pull of the Moon and Sun. Answer: C. Gravitational pull of the Moon and Sun. The Moon's gravity pulls Earth's ocean slightly toward it, creating high and low tides along with smaller effects from the Sun. What is a new moon? A. When the Moon is fully lit by the Sun. B. When the Moon is not visible from Earth. C. When the Moon passes through Earth's shadow. Answer: B. When the Moon is not visible from Earth. A new moon occurs when the Moon is positioned between Earth and the Sun, its lit side facing away from us. Section 8. Planets in detail. Each planet has its own personality, some scorched, some frozen, some cloaked in storms or wrapped in rings. By studying them, we learn more about Earth and the wide range of what home can mean in a universe full of worlds. Which planet is closest to the Sun? A. Venus. B. Mercury. C. Mars. Answer: B. Mercury. Mercury is the smallest and innermost planet, its surface scorched by solar radiation and long airless days. Which planet has a thick atmosphere of carbon dioxide and a surface hot enough to melt lead? A. Mars. B. Earth. C. Venus. Answer: C. Venus. Venus has a runaway greenhouse effect, trapping heat beneath clouds of carbon dioxide and sulfuric acid. Which planet is known for its large red storm called the Great Red Spot? A. Jupiter. B. Saturn. C. Uranus. Answer: A. Jupiter. Jupiter's Great Red Spot is a massive storm larger than Earth, raging for centuries in its gas-filled atmosphere. Which planet is the only one known to support life? A. Mars. B. Earth. C. Neptune. Answer: B. Earth. Earth is the only known world with liquid water on the surface, a stable atmosphere, and life in stunning variety. Which planet has the largest ring system in the solar system? A. Saturn. B. Uranus. C. Jupiter. Answer: A. Saturn. Saturn's iconic rings are made of ice and rock, extending hundreds of thousands of kilometers from the planet's surface. Which planet rotates on its side with an axial tilt of about 98 degrees? A. Uranus. B. Neptune. C. Venus. Answer: A. Uranus. Uranus is tipped nearly sideways, possibly due to a colossal impact early in its history, causing extreme seasonal changes. Which planet is known for its brilliant blue color and supersonic winds? A. Mars. B. Jupiter. C. Neptune. Answer: C. Neptune. Neptune's deep blue hue comes from methane in its atmosphere, and its winds are the fastest in the solar system. Which planet is often called the Red Planet? A. Mars. B. Mercury. C. Earth. Answer: A. Mars. Mars gets its rusty color from iron oxide, dust that covers its surface and gives the planet a reddish glow. Section 9. Moons and dwarf planets. Beyond the planets lie frozen worlds and strange companions. Some moons have oceans beneath their crusts. Others spew ice volcanoes or orbit backward. And dwarf planets? They remind us that not all great stories come in large packages. Which moon is larger than the planet Mercury? A. Europa. B. Titan. C. Io. Answer: B. Titan. Saturn's moon. Titan is the second largest moon in the solar system, and even bigger than Mercury. What makes Europa, a moon of Jupiter, especially interesting to scientists? A. It has volcanoes made of iron. B. It contains underground cities. C. It may have a subsurface ocean beneath its icy shell. Answer. C. It may have a subsurface ocean beneath its icy shell. Europa's cracked frozen surface hides a global ocean, making it a prime candidate in the search for extraterrestrial life. Which planet's moon, Triton, orbits in the opposite direction of the planet's rotation? A. Uranus. B. Neptune. C. Jupiter. Answer. B. Neptune. Triton is likely a captured object from the Kuiper Belt. Its retrograde orbit suggests it didn't form around Neptune. Which moon is known for its extreme volcanic activity? A. Titan. B. Callisto. C. Io. Answer. C. Io. Io, a moon of Jupiter, is the most volcanically active body in the solar system, with eruptions powered by tidal heating. What led to Pluto being reclassified as a dwarf planet? A. Its icy composition. B. It lacks a solid surface. C. It hasn't cleared its orbital path of other debris. Answer. C. It hasn't cleared its orbital path of other debris. In 2006, Pluto lost its planet status because it shares its orbit with other icy bodies, failing one criterion for full planetary classification. What is the Kuiper Belt? A. A ring of moons around Saturn. B. A distant region beyond Neptune filled with icy bodies and dwarf planets. C. A gap in the asteroid belt. Answer. B. A distant region beyond Neptune filled with icy bodies and dwarf planets. The Kuiper Belt includes Pluto, Haumea, and Makemake, and is the source of many comets. What is Ceres? A. A Martian moon. B. An asteroid with no atmosphere. C. A dwarf planet located in the asteroid belt. Answer. C. A dwarf planet located in the asteroid belt. Ceres is the largest object in the asteroid belt between Mars and Jupiter, and the first dwarf planet ever discovered. Section 10. Exoplanets and Habitability. Beyond the glow of our sun lie countless other stars. Encircling them, billions of planets. Some are fiery, others frozen, and a few may orbit in just the right zone to cradle life. We haven't found another Earth yet, but we're listening. What is an exoplanet? A. A small moon orbiting Earth. B. A planet that orbits a star outside our solar system. C. A planet without an atmosphere. Answer. B. A planet that orbits a star outside our solar system. Exoplanets are worlds beyond our solar system, discovered by watching their stars wobble, dim, or pulse. Which method detects exoplanets by measuring tiny dips in starlight as a planet passes in front of its star? A. Transit method. B. Direct imaging. C. Spectral lensing. Answer: A. Transit method. The transit method monitors brightness, detecting planets when they eclipse a small portion of their star's light. What defines the habitable zone around a star? A. Where planets orbit fastest. B. Where water can exist as a liquid on a planet's surface. C. Where temperatures never exceed freezing. Answer: B. Where water can exist as a liquid on a planet's surface. The habitable zone, sometimes called the Goldilocks zone, is not too hot, not too cold, but just right for liquid water. Which space telescope was launched to discover Earth-like planets? By the transit method? A. James Webb Space Telescope. B. Hubble Space Telescope. C. Kepler Space Telescope. Answer: C. Kepler Space Telescope. Kepler revolutionized our understanding of planetary systems, confirming thousands of exoplanets since 2009. Which telescope is designed to study exoplanet atmospheres in detail? A. Chandra X-ray Observatory. B. James Webb Space Telescope. C. Voyager 1. Answer: B. James Webb Space Telescope. JWST observes infrared light, allowing it to analyze exoplanet atmospheres for water vapor, carbon dioxide, and other life-related gases. Why is it difficult to directly image exoplanets? A. Planets are too bright. B. They move too slowly. C. The light from their stars overwhelms their own faint light. Answer: C. The light from their stars overwhelms their own faint light. Exoplanets reflect very little light, and their stars can be billions of times brighter, making direct detection challenging. What is a super-Earth? A. A planet with more gravity than Jupiter. B. A type of black hole. C. A rocky planet larger than Earth but smaller than Neptune. Answer: C. A rocky planet larger than Earth but smaller than Neptune. Super-Earths are common in the galaxy, and some may be habitable, though none have been found to host life yet. Section 11. Galaxies. Galaxies are vast, collections of stars, gas, dust, and dark matter, bound together across time and gravity. Some spiral, some stretch, some collide and merge, dancing through the void. Our own Milky Way is just one of billions. What is a galaxy? A collection of comets orbiting a planet. B, a system of millions or billions of stars, gas, and dust held together by gravity. C, a layer of Earth's upper atmosphere. Answer: B, a system of millions or billions of stars, gas, and dust held together by gravity. Galaxies are the fundamental building blocks of the universe, each containing stellar neighborhoods, star nurseries, and black holes. What type of galaxy is the Milky Way? A, elliptical galaxy. B, irregular galaxy. C, spiral galaxy. Answer: C, spiral galaxy. The Milky Way is a barred spiral galaxy with arms that wind outward from a bright central bulge. What is at the center of most galaxies, including our own? A massive star. B, a nebula. C, a supermassive black hole. Answer: C, a supermassive black hole. Most large galaxies contain a black hole at their center, millions or even billions of times more massive than our Sun. Which type of galaxy has no clear shape or structure? A, irregular galaxy. B, spiral galaxy. C, elliptical galaxy. Answer: A, irregular galaxy. Irregular galaxies lack defined shape, often formed through collisions or gravitational distortions. What are elliptical galaxies generally shaped like? A, flat disks with spiral arms. B, perfect spheres only. C, rounded football-like shapes with little gas or dust. Answer: C, rounded football-like shapes with little gas or dust. Elliptical galaxies tend to be older and contain fewer young stars, often appearing smooth and dim. What is the name of the galaxy moving toward the Milky Way for a future collision? A, Triangulum Galaxy. B, Andromeda Galaxy. C, Whirlpool Galaxy. Answer: B, Andromeda Galaxy. The Andromeda Galaxy is on a slow-motion collision course with the Milky Way, expected to merge in about 4 billion years. What do astronomers call a group of galaxies bound together by gravity? A galactic shield. B, a light field. C, a galaxy cluster. Answer: C. A galaxy cluster. Clusters may contain hundreds or even thousands of galaxies, along with hot gas and dark matter. Section 12. Cosmology and Dark Matter. Cosmology asks the biggest questions. Where did it all come from? What is the shape of time? Why does the universe expand, and what invisible forces hold it together? Dark matter and energy remain unseen, but their fingerprints shape the cosmos. What is cosmology? A. The study of beauty products in zero gravity. B. The study of the origin, structure, and evolution of the universe. C. The practice of naming stars. Answer: B. The study of the origin, structure, and evolution of the universe. Cosmology is a branch of astronomy that explores the big picture, how the universe formed, changes, and may eventually end. What is dark matter believed to do in the universe? A. Produce most of the light we see. B. Emit powerful radiation from quasars. C. Add extra gravity that holds galaxies together. Answer: C. Add extra gravity that holds galaxies together. Dark matter doesn't emit light, but its gravity explains why galaxies spin faster than visible matter alone can account for. What percentage of the universe is thought to be made up of dark matter and dark energy combined? A. About 5%. B. About 27%. C. Over 95%. Answer: C. Over 95%. Only about 5% of the universe is ordinary matter. Everything else is made of dark matter and dark energy. What is dark energy believed to be responsible for? A. Compressing galaxies into black holes. B. Slowing the universe's expansion. C. Accelerating the expansion of the universe. Answer: C. Accelerating the expansion of the universe. Dark energy is a mysterious force that counteracts gravity, causing the universe to expand faster over time. Which observation supports the existence of dark matter? A. The colors of stars changing at sunset. B. Galaxy rotation curves that show stars moving faster than expected. C. Eclipses appearing longer than usual. Answer: B. Galaxy rotation curves that show stars moving faster than expected. Without extra unseen mass, galaxies would fly apart. Dark matter provides the extra gravity to keep them bound. What do scientists use to study the universe's earliest moments? A. Seismic waves. B. cosmic microwave background radiation. C. The tides. Answer. B. Cosmic microwave background radiation. The CMB is a faint afterglow from about 380,000 years after the Big Bang, our oldest visible light from the early universe. What is a singularity? A. A type of star. B. A region of infinite density, such as the center of a black hole. C. A place where time stands still. Answer. B. A region of infinite density, such as the center of a black hole. Singularities are where the known laws of physics break down. Extreme points of space and time within black holes, or possibly the Big Bang itself. Section 13. Black holes and neutron stars. Some stars don't just die, they collapse. What's left behind can bend light, twist time, and swallow matter whole. Black holes and neutron stars are the densest objects in the universe, mysteries wrapped in gravity. What is a black hole? A. A collapsed planet. B. A region of space with gravity so strong that not even light can escape. C. A shadow in space caused by dark energy. Answer. B. A region of space with gravity so strong that not even light can escape. Black holes form from collapsed stars, compressing mass into an incredibly small point with the gravitational pull that traps light itself. What is the event horizon of a black hole? A. Its glowing outer edge. B. A time loop near a star. C. The boundary beyond which nothing can escape. Answer. C. The boundary beyond which nothing can escape. The event horizon marks the point of no return. Once crossed, all matter and radiation are pulled into the black hole. What is a neutron star? A. A type of comet. B. The collapsed core of a massive star made almost entirely of neutrons. C. A moon with high radiation. Answer. B. The collapsed core of a massive star made almost entirely of neutrons. Neutron stars are ultra-dense remnants of supernova, so compact that a teaspoon would weigh billions of tons. What is a pulsar? A. A planet that rapidly orbits a black hole. B. A neutron star that emits beams of radio waves as it spins. C. A fading galaxy core. Answer. B. A neutron star that emits beams of radio waves as it spins. Pulsars are rotating neutron stars, flashing like cosmic lighthouses as their energy beams sweep past Earth. What causes a supernova? A. A collision between two planets. B. The death of a massive star that can no longer support its own weight. C. A meteor hitting a star. Answer. B. The death of a massive star that can no longer support its own weight. When a massive star runs out of nuclear fuel, its core collapses and the outer layers explode, creating a supernova. What happens to light near a black hole? A. It speeds up. B. It bends and slows due to extreme gravity. C. It reflects back toward its source. Answer. B. It bends and slows due to extreme gravity. Black holes warp space-time, bending light around them and making nearby stars appear stretched or duplicated. What recent achievement helped visualize a black hole for the first time? A. Launch of the Hubble telescope. B. The Event Horizon telescope captured a photo of a black hole's shadow. C. A supernova exploded near Earth. Answer. B. The Event Horizon telescope captured a photo of a black hole's shadow. In 2019, scientists revealed the first image of a black hole silhouette, confirming theories and sparking awe worldwide. Section 14, Space Exploration Emissions. From backyard stargazing to boots on the moon, human curiosity has always pointed upward. Rockets, satellites, and probes have carried our dreams across the void, seeking answers, samples, and someday home beyond Earth. What was the first artificial satellite launched into space? A. Apollo 11. B. Sputnik 1. C. Voyager 1. Answer. B. Sputnik 1. Launched by the Soviet Union in 1957, Sputnik 1 was the first human-made object to orbit Earth, marking the start of the space age. Who was the first human to travel into space? A. Neil Armstrong. B. Yuri Gagarin. C. Buzz Aldrin. Answer. B. Yuri Gagarin. In 1961, Soviet cosmonaut Yuri Gagarin orbited Earth aboard Vostok 1, becoming the first person in space. Which mission first landed humans on the moon? A. Apollo 13. B. Gemini 5. C. Apollo 11. Answer. C. Apollo 11. In 1969, Neil Armstrong and Buzz Aldrin set foot on the moon, leaving boot prints and the words, "That's one small step for man." What spacecraft has traveled the farthest from Earth? A. Hubble Space Telescope. B. Voyager 1. C. New Horizons. Answer B. Voyager 1. Launched in 1977, Voyager 1 is now in interstellar space, still sending signals home from over 15 billion miles away. Which rover discovered evidence of ancient water on Mars? A. Opportunity. B. Curiosity. C. Spirit. Answer A. Opportunity. NASA's Opportunity rover found sediment patterns in minerals that formed in water, hinting at a wetter past for Mars. What is the International Space Station, ISS? A. A telescope orbiting Jupiter. B. A satellite that maps Earth's core. C. A habitable spacecraft in Earth's orbit used for research. Answer C. A habitable spacecraft in Earth's orbit used for research. The ISS is a joint project involving many nations, where astronauts live and work in microgravity. Which telescope has captured some of the most detailed images of distant galaxies? A. Hubble Space Telescope. B. Kepler Space Telescope. C. Chandra X-ray Observatory. Answer A. Hubble Space Telescope. Since its 1990 launch, Hubble has provided breathtaking images of nebulae, galaxies, and deep space, reshaping our view of the cosmos. What is Artemis, NASA's next-generation program? A. A robotic comet chaser. B. A plan to colonize Venus. C. A mission to return humans to the Moon and eventually Mars. Answer C. A mission to return humans to the Moon and eventually Mars. The Artemis program aims to land the first woman and next man on the Moon, paving the way for human missions to Mars. Section 15. Astronomical Tools and Measurement. How do we measure a star we cannot touch? How far is a galaxy that's only a speck of light? Astronomy depends on clever tools and clever math to turn distant photons into cosmic knowledge. What is a light year? A. The time it takes light to circle Earth. B. The distance light travels in 1 year. C. The time it takes Earth to orbit the Sun. Answer B. The distance light travels in 1 year. A light year is about 588 trillion miles, used to measure vast cosmic distances. What do astronomers use to split light into its component colors for analysis? A. A lens. B. A magnetometer. C. A spectroscope. Answer. C. A spectroscope. Spectroscopes let astronomers determine what stars are made of, how fast they're moving, and even their temperatures. What is parallax used to measure in astronomy? A. Time dilation. B. Distance to nearby stars. C. The temperature of exoplanets. Answer. B. Distance to nearby stars. By observing how a star's position shifts against distant backgrounds, from different points in Earth's orbit, astronomers can measure its distance. Which scale is used to describe the brightness of celestial objects? A. The Richter scale. B. The Kelvin scale. C. The magnitude scale. Answer. C. The magnitude scale. The magnitude scale measures how bright an object appears from Earth. Lower numbers mean brighter objects. What unit is commonly used to express distances within our solar system? A. Light year. B. Astronomical unit. C. Parsecs. Answer. B. Astronomical unit. 1 astronomical unit, abbreviated AU, is the average distance from Earth to the Sun, about 93 million miles. What is triangulation in space science? A. A method for predicting eclipses. B. A technique to measure an object's mass. C. Using angles from 2 known positions to calculate distance to a third. Answer. C. Using angles from 2 known positions to calculate distance to a third. Triangulation, used in parallax, relies on simple geometry to measure things too far to touch. What is a parsec equivalent to? A. About 3.26 light years. B. The distance from Earth to Mars. C. 1 billion kilometers. Answer. A. About 3.26 light years. The parsec is another unit for cosmic distance, used especially in measuring deep space objects.